Okay, day 1, 1.1, functions, domain, and range. Domain is the set of all values for which the independent variable is defined. Basically, we're looking at all the possible x values. That's what domain is asking for. So these definitions you need to understand because we're going to be using this frequently throughout the course. So domain is the x values. How do the x values play across a graph? We'll be looking at examples of this in this whole entire course, but specifically in this section. Range is the set of all values of the dependent variable. Now what that means is that these are determined from the domain. So range is all the dependent variable. So the y values. We all remember from grade 9 that the y values depend on the x values. So here we're looking at the range values, which is the y. What range do the values go? So again, it's the y values, which is the range. And we're going to be looking at this throughout this course. So this terminology, domain, range, and other terms we're going to be talking about in this section have to be understood so that when these words come up again and again, it's not repeated. So this definition you must know. Now, again, these are critical terminology that is used throughout the course. Okay, next definition is a function. What is a function? A function is a relation in which there is only one value of the dependent variable for each value of the independent variable. Basically, what we're looking at here is this is the formal definition of a function. So we'll just call this definition number 1. There's a second definition, which is a lot easier to remember, and it means the exact same thing as definition 1, but in a little more simpler language. And that is, for every x value, there is only one y value. So there can only be one y value for every x. All right? So that's definition number 2. And there's a third definition, which we'll discuss, and that third definition applies to graphs. And applies to graphs only. And that is, the definition of a function satisfies the vertical line test. So we're going to be looking at what a vertical line test in a little bit to understand how that applies to functions and non-functions. So that's another definition you must know. You won't necessarily need to know definition number 1, but for certain you're going to need definition number 2. This is very important. And definition 3 we'll use backwards. We'll use it when it doesn't satisfy the vertical line test. But we'll look at examples shortly for this. All right. Now, before we begin to understand domain, range, and functions, we have to start with the idea of what a relation is. What is a relation? A relation is every graph, every equation, every table of values. In fact, we're going to even see another one called mapping notation is known as a relation. Anything that can be graphed is known as a relation. A special relation, and only special types of relations, are called functions. These special relations, called functions, follow a specific rule that says that for every x value, there is only one y value. And that's very important to remember. For every x, there is one y. Most important definition of the 3 we just looked at. Now, what else is to note is that domain and range can be stated both for functions and for relations. And these x and y values, x being the domain and y being the range, can be expressed one of two ways. So there are going to be two ways that you're going to learn. In grade 11, we look at set notation to express the domain and range. In grade 12, we learn interval notation. I am going to introduce both a little later on so that you understand how to do both, but specifically I'll be testing for set notation in grade 11. Okay, now, examples of set and interval notation. So we're going to look at some simple examples first before we go into more complicated examples. So looking at a straight number line, so let's think of it as the x-axis. We're going to be looking at values across the x-axis. So let's say we have this one, where it starts at -3, including -3, and goes on forever towards the right. What does that mean? Well, it means that the domain of the function x is real numbers such that x is greater than or equal to -3. And we close the bracket. Something to note is this curly bracket over here. You make a curve, a bump, and another curve to create that curly bracket. These are set brackets reserved for set notation. X implies it's the domain. If it was the range, it would be y. This means belongs to. So x belongs to the following function. So then this symbol over here mathematically means such that. So x belongs to all real numbers. That's what this is. How do you draw real numbers? It's a double bar, and we make the R with the first bar. Okay? That implies that these are all real numbers. We're going to talk about what real numbers means right now. There are such numbers as natural numbers, whole numbers, integer numbers, rational numbers, irrational numbers, and real numbers. Okay? What are these kind of numbers? It has to do with understanding the growth of numbers as you learn them when you first start to learn numbers. Natural numbers is you begin counting naturally on your fingers. You're introduced to the number 0 very shortly. Okay, whole numbers. Then you're introduced to integers. You're introduced them a little earlier if you're born in the winter time. And later on in your educational career, you're introduced to fractions and decimals. Those are known as rational numbers. Any number that can be expressed as a fraction, any decimal that can be expressed as a fraction, is known as a rational number. And then there are such things as irrational numbers. Those are numbers that never repeat, never terminate, and decimals that do that, so such as pi. That is a number that is known as irrational. And real numbers means basically anything that I can graph on a real graph as such that includes all the possible numbers inside here. So all the possible numbers. Pi would be in here. 0.000000001 is in here. Negative 2.999999999 continuing is in here. So the idea is it's all the possible numbers that fit in here. Those are real numbers. They can be really graphed on a graph. How does this help us? Well, you have to understand that in set notation, it must apply to some set of numbers, in this case real numbers. This means such that, and finally this means the restrictions on the x, so the such that x is greater than or equal to, this is it, equal to -3. How do we know it equals? Let's go back up here. This big orange dot is a closed circle. It's colored in. When it's colored in, it's closed. That means we include the -3 in our information. All right. Don't forget that the curly brackets are known as set brackets. We need those to answer our questions. Okay, and that, folks, is the set notation for this line graph. All right, and this just talks about the world of numbers. We're going to just kind of go through this really quickly. We've done this in class, so I'm not going to really describe it in detail, but this is the idea of the world of numbers, how we first began counting. All right, next, looking at that number line, same number line we just had, folks. Okay, and this number line we're now going to express in interval notation. How are we going to do this in interval notation? Well, interval notation is the description of how this begins to how it ends. Okay, so x belongs to, and we start off with a square bracket. Why? Because we're including that -3. Means that the number actually starts exactly at -3. Because of that, we include it, so it's closed bracket, -3, all the way up to infinity, folks. And think about it. Does infinity have an end? And the answer to that is no, so we're going to have a round bracket at the end. And this, folks, is interval notation. This means we have a hard beginning at -3, and it goes off to infinity forever and ever and ever. So there's a soft ending to this, meaning that we don't actually reach a hard end. Okay, and this means the domain, so x belongs to the interval from -3 all the way up to infinity, including the -3. Don't forget, we're including that -3. All right. Keep in mind that there's a closed bracket. When it's square, it means it's a closed circle, a closed dot, a hard start, or a hard end. And infinity will always have a round bracket. Okay, infinity always has a round bracket. Also, a round bracket would imply there's an open circle, so one or the other. In the case of infinity, though, because it never really has an end, okay, and because it never has a real end, we use a round bracket. It can never, ever, ever be square at infinity. Okay, another example. If I give you the following in set notation, you're asked to graph and write in interval notation. Now in grade 11, I do not have to test you on interval notation, but what I do is I make sure that you are, you're at least given an opportunity to show me a different notation for some extra incentives. Okay, so what is this saying? X belongs to real such that x is less than 2. Okay? Less than 2. So, what does that mean? Well, when we graph it, we will have all, now how many ticks we need? We need 7 ticks, folks. A minimum of 7. Here they are. 7 ticks. Okay, and we put the middle number as the number inside that set notation, which is 2. And then we fill in all the other numbers as such that you see here. And now we want on 2, we want an open circle because we're not including the 2, we're talking about less than 2. So 2 and all the numbers less than 2. All right, and that is our graph. Interval notation, x belongs to real, such that, sorry, not such, x belongs to the set from round bracket, so it starts at negative infinity and goes all the way up to 2. And this, folks, is the description of what this line does. Starts at negative infinity and goes all the way up to 2 round bracket at 2 because it gets really, really close to 2. Let's say 1.99999999999, but not exactly 2. So that's what this open circle means there. See an open circle, you have an open bracket, rounded bracket. Okay, next one. You're asked to graph and write in set notation. X belongs to the interval from -6 to -1. What does that mean? Well, let's look. We have a square bracket at the -6. We have a round bracket at -1. And that's what we need to solve. So we're asked to graph from -6 all the way to -1. Remember, you need at least 7 ticks. Do a little bit extra to show what the numbers are doing. At -6, we put a closed circle. At -1, we put an open circle. And we connect between there because it's saying the numbers from -6 to -1, including -6, but not -1. Set notation means the following. X belongs to real such that X is between numbers. What numbers is it between? Well, it starts at -6 and it goes to -1. The question that people have is, what sign do we put in here? Well, folks, we always read from the X. We know all the numbers are going to be bigger than -6. So when you read it backwards. X is bigger than or equal to -6, and X is smaller than -1. So that is the form that it has to look. When I'm reading this, I read X is bigger, there's a bigger opening here, or equal to -6, and X is less than -1. Okay, next, you're asked to express the graph in set and interval notation. So here's another set of graph, okay, and you're asked in this graph to express in set and interval notation. So what is this saying? Well, this is saying it starts over here, which is known as -infinity, goes up to -2, open circle at -2, and then we do a jump, start again at 3, close circle on 3, and continue off towards infinity. So set notation means that we're going to have two pieces. X belongs to real. Yes, almost always do we start the same way each time, folks. Such that what conditions are placed on X? Well, X has to be less than -2 or greater than or equal to 3. Now, there are two ways to express the or. Or is an English word, not necessarily understood around the world. So, sometimes what we place instead of or is the symbol, this U symbol, which means this piece or this piece is happening on the same graph. You cannot write two separate set notations because, again, it expresses one graph. Interval notation is X belongs to from -infinity to -2, or, remember the symbol, now you can use the word or, I'll accept that, from 3 square bracket to infinity. Don't forget that at -2 it's rounded because it's an open circle, and at 3 it's a square bracket because at 3 up here it is a closed circle. All right, next on here, let's look at the next example. What happens in this case? What do we do here? Let's express this in set notation. Set notation says that, well, we're going to go from -infinity all the way up to infinity with the exception of this one number over here. What's that number? 1. So we rewrite this as X belongs to real such that X does not equal 1. And that's it, folks. This is the only time interval notation actually looks uglier than set notation. And that is the case when we have a non-value. So x belongs to from -infinity to 1, round bracket, or from 1 to infinity. Again, round bracket at the 1 because of the fact that it's an open circle at the 1. And we write it as two separate pieces. Okay. So we're just going to ignore this piece here, folks. Okay. What's important to know is how to do set and interval notation. So hopefully this has helped you understand set and interval notation. Take care. Have a numerical night.